To perform well, machines need to stay cool. And for some time, a small company in Florida has been helping NASA keep its machines cool. In 1988, Mainstream Engineering Corporation first partnered with NASA's Goddard Space Flight Center through the Small Business Innovation Research, or SBIR program, on a project to develop a heat pump for spacecraft. The heat pump design was for heat rejection.
They needed a more efficient means to get rid of heat, which means they'd consume less power, and power is a difficult thing to find on a spacecraft.
The design worked, and Mainstream knew that if they were successful in meeting NASA's heat pump needs, they would also have a very useful commercial product. The result was QwikBoost, a low-cost performance-enhancing additive that works by increasing the cooling capacity of a refrigerant. QwikBoost products are now sold everywhere and are also used by NASA. Today, that same research and development for a better heat pump is being fed into a new NASA SBIR project with Johnson Space Center for a lunar planetary heat pump.
20 years later, we are now building a demonstrator for NASA to demonstrate that this technology would be the way to get rid of heat when they build that base.
Besides helping to cool machines, Mainstream has also worked with NASA to keep people cool. Through SBIR funding from Kennedy Space Center, the firm developed an improved heating and cooling system for self-contained atmosphere protective ensemble, or SCAPE suits. NASA personnel wear the airtight suits while performing activities with hazardous or unknown materials. In 2005, Mainstream delivered an oilless microgravity refrigeration compressor to Lockheed Martin. The firm developed the compressor by building on technologies from previous SBIR projects with NASA and other federal departments.
We designed one for them, which met all the performance requirements, and then we actually, on our own money, went back and made some design changes and then got a SBIR Phase 1 to improve the design.
That compressor is now attached to a refrigerated centrifuge in the Human Research Facility on the International Space Station. Under an SBIR contract in the early 1990s from Johnson, Mainstream devised a method to use computational chemistry to identify new fluids. By entering the properties for the desired fluids, chemical engineers can identify potential compounds by reverse engineering the chemical structure that will provide the specified properties. On their current SBIR contract with Johnson, the company is again relying on that same method to identify a potential new fluid. They're working on a superwater with a low freezing point that can also be used in the space vehicles.
Even the things that we're doing in nanotubes, which may sound like it's completely out in left field, they're connected because we're looking at improving heat transfer.
For Mainstream, the complete thermal control system, the heat pump, the exchangers, the new fluid, they're all about keeping things cool.